Hi all, my name is Jen Morgan and I'm the Virginia program lead for Riot. Welcome to the Riot Lunch and Learn series, the place where we spotlight Riot sponsors. Today we have with us Will Darden with Device Solutions to discuss learn how to avoid the pitfalls of product development. Just a couple of quick reminders before we get started. This event is being recorded and will be posted to Riot's YouTube channel and uploaded to the meetup page where you registered for this event. If you have any questions throughout the presentation, I will be monitoring the chat. Please place all your questions in the chat. I will read the questions aloud throughout the presentation and have Will answer them as we go. Please keep yourself muted throughout the entire presentation. And with that being said, I will turn it back over to Will.
All right, thank you, Jen. So we'll start with product development. I'll walk you guys through this. If you do have a question during it, just put it in the message, and then we'll definitely hit some at the end as well. I'll tell you a little bit about the company and myself before we get rolling. Device Solutions, we're about 20 years old, starting in 2003. Product development company, and we do everything on the inside. So the embedded hardware, the firmware, RF and antenna, because we do a lot of wireless products, and we'll help get you through regulatory FCC and carrier approvals, AT&T, Verizon, T-Mobile. And myself, I've been in the industry about 30 years. Half the time has been with handset OEMs or telematics, M10 type programs, and half in design services. I'm an antenna guy by training, and I've also run a few larger programs in my time. And so I'll try to teach you at least a few things I've learned. It's product development in the context of IoT. So I have blue for just some generalities of a product or development or a program, and then some orange. Orange will be your code for IoT specific things. And again, this is just based on my experience, things that I've seen. Mileage may vary. All right, so IoT, it's we do hear quite a lot about it. It can be greatly simplified, right? It's just moving data at the highest level. So data in, data out, usually up to a cloud or most of the time. The data comes from sensors, which can be just about anything. It will move through a central microprocessor, and then it moves up over a radio, a wireless link. And again, there's always corner cases, but in general, this is what you get. GPS is an interesting sensor because it's actually a radio itself. And you definitely get a lot with GPS, but that's where we start. Okay, major generalities if you have a program. This could be just anything, and a lot of this is common sense, but you need to be fairly tactical. So any key dependencies you need to line up in a schedule, and you're going to put long lead items first. You're not going to put those last. You're going to size this thing up. I'm going to focus on this. Discovery is a big deal. I've got a slide on that, and it's distributed across time. It's a human endeavor, discovery, and it's an imperfect thing, but it's a very necessary thing. Another point is balance, and you guys may see this. This really is a balance of risk and progress, right? If you move too far to either side and forget the other, you will be in trouble. So you always want to keep that in mind and try to balance those two out. System cost. I've got one example here, but there are a bunch. So you do want to, it always costs money to develop something. So you need to think about any action you have, what it may have to that total cost. So for example, we'll say you need to re-engineer something to save a quarter on a bill of materials. Could be a $30 bill of materials, right? But savings is good. How many hours would you invest in that? Well, there's a simple calculation, right, to get the return on investment. What you need to know is your quantity, right? So if you're doing 10 million units, well, that'll get your attention real quick. If you're doing 1,000, you may pass up on that. So that's one example. The math is straightforward. You'll see another one. We bring it up to radios. You can get a pre-certified radio, or you can do a chips down design where you have to go through a dedicated certification effort, which costs both dollars for cert labs and time to steward it through the process. And there are trade-offs there. And again, that one depends on volume, production volume. It's a general thing you always want to keep in mind, though, that some action may cost you more money in an unintended way. This is again a common sense thing. You know, risks. Sometimes I'd say that term risks may be overused, maybe depending on your environment. Minor risks will not kill your project. So you don't want to be over consumed with a minor risk for sure. Major risks, you do want to be consumed with those. So these are project just explodes, right? Something nonlinear happens, and it can really kill something. So one of the things that I have seen for this is there may be a new chip coming out and it promises, you know, twice of what any other previous chip capability could do, but it's not yet on the market, right? You can place a bet with that, but if that guy slips schedule, then you just slip schedule. Or if their performance comes out and it can't quite meet the advertised performance, then your product will suffer. So I have definitely seen that kill projects in spectacular ways. So be aware of these different things, think about them, and maintain your perspective through the program to say, hey, is this a big deal or not a big deal? The other one that can happen, which is unfortunate and preventable, is just downstream work. So if you do have to go back and do something over, it can hurt or kill a program. All right, discovery. So I want to tell you, I was thinking about this morning. I think this is the slide from the presentation because discovery drives everything, right? So this is the customer, in this case, is deciding what they want to do. You know, what is this product going to look like? What's it do? Experience, and yes, is it producible? Cost. So here's what I'd call is a typical discovery curve. As you start ahead of the hardware and software efforts, for sure, decide what you want, right? You put time into it, you sleep on it, you refine it. But at this point, there has to be a point where it goes down. Keep my mouse a second here. Yeah, where it goes down. If it were to do bad things, like if it were to start at a higher rate, you will most likely run out of budget. And I've seen that, unfortunately. So you don't want that to happen. You have to get this to converge. If the discovery process doesn't converge, the work will never converge, which means the budget won't. So you do have to have a clear goal to leave this phase. And when I say goal, that's actually a date too. So whatever, if you're going to be 1 month, 2 months, or 3 months, but you have to leave that. If this were to go up, another one goes up and it stays here, that it just kills it. So that's a very important thing. Just a little bit of context here is the hardware when you go through this process, you'll say, hey, I want GPS, I want a pressure sensor, et cetera. This is fairly closed. You're going to have a build of hardware and it's delivered, and then the product's delivered to the end customer. Software always has that potential, right? Let's put in an extra feature, things of that nature. And those are typically, that we'll call that late discovery. It can fuel late software development as well. So, you know, think about this a lot. Think about it in the front part, but don't pursue it forever. That's the fountain of youth concern. You have to close it off. And this is the old adage, measure twice, cut once. Architecture. So we're going to say it again, do your discovery until it hurts. When we go below this to all of these bullets, these are, this is where we roll in. Any company would do this. You're rolling in a real team. You're paying real mortgages at this point. So you want to do this once and do it the right way. You do not want to do it a second time. So yeah, we'll dive into each of these on a fast task. So radio bearers, you're going to get into the cloud. They're different paths. Like I said, you could have certifications could be part of it. Do you use a certified radio or not? Do you want to pay fees? And sometimes you do want to have monthly fees like you would with an AT&T or Verizon. Power consumption, different radios pull different amounts of power, and antenna size. Another, consideration would be frequency. For example, in building applications work better with lower frequency, so you get better penetration through walls and things of that nature. So it's very, very system dependent. You want to make a good choice for this earlier. This one I mentioned. This is one to get people to think about too, is sometimes people will balk at an AT&T and Verizon as an example, because they don't want to see a bill. But the data has gotten incredibly cheap. So you could say, while not free, it's becoming practically free. And that has a trade-off where, users just pull out of the box. You've got national coverage. They're the benefits of that network that you're paying for. So I wouldn't rule it out just because there's a small cost associated with it. So think about that. Another one here, and you're going to see this theme several times. Pick the top 2 to 3 vendors when you're looking. Let's say you pick cellular. Go look at the top 2 or 3. Talk to those guys. You're going to look at performance, availability, costs. As you go away from the top 2 or 3, I've found you run the risk of things, like I said, that could be nonlinear. Probably the primary thing would be poor support. Usually the top 2 or 3 are the top guys for a reason. Support is a very nonlinear thing. If you've gone, deep into this process and you find you can't really use a part because there's no support, then that's a big issue. And I do recommend actually getting on the phone, talking to these guys in all cases. Sensors are easy. There's tons of choices. They're pretty cheap. You may find a company that wants to sell you a suite of products. You do not have to have that. Again, pick from the top 2 to 3, talk to these guys, and they're always dying to talk to people. Processors. This is an interesting one. And I'm going to tell you, it can be very easy. It's very competitive. There are a million varieties of processors out there. Even if you're talking to one vendor, they've got a ton of options. One thing you do want to look at is, do they have firmware libraries that you can utilize and save on the firmware side? That's a system cost concept. In general, you need plenty of memory. You will never see a program that at the end of the program needs half or less memory than originally thought. It only goes up. So, get enough memory, and then ideally check the available parts to see if they have other options with twice as much or for much in case you have an inflation over the project. Look at the the interfaces, digital interfaces. Again, pick the top 2 or 3, but this is why this is easier. Processors are easier. Is you might be looking at a 16 or 17 ounce hammer. Which one is better? The answer is they both do the job. So if you do have a couple of offerings that are competing for your design, don't get too hung up on it. They probably all work just fine. And then you just move on. Batteries. So a lot of devices are portable, battery operated. It's everywhere today. So you need to make some decisions in terms of battery. It's a limited resource, right? And there is a trade-off, and this is sometimes I think a lot of people know this, and a lot of people maybe would choose not to know it or not confront it. So you either have to pick, let's say you have a wearable and you want the smallest wearable in the world. That means you're going to have a smaller battery. And if your battery is smaller, you have less battery longevity. And that's just the way batteries work. So to make a good balanced decision, you'll start early with a current estimator to say, a transmission is so many milliseconds, it consumes so many milliamps, and estimate on paper, on a spreadsheet, what the battery will, how long it'll last. The other one, which is common sense, but the less you use the battery, the longer it lasts. And some people they would prefer to think that there's some type of magic to make a battery last longer. And I'll tell you, the real magic that's there is to give the human perception that it is doing a lot, but make the product go to sleep as much as possible to give the battery a break. And it's just a very straightforward thing. The other thing in the process is keep in mind, you will never have enough battery. So whether that's that's a wearable or whether that's an electric vehicle, whatever it is, you could always use more battery, but essentially you have to make a decision, pick a size, and move on. This too, I have seen people turn into a fountain of youth concern where they want a third the battery or 3 times the life of their competitor, and there's got to be a way to get there. And most of the time there is not, unless the competitor did something poorly, but that's usually not the case. Antennas. Okay, this is an interesting one too. So if you have a plastic housing over a PCB, it's pretty natural to think that there's an interdependency there, right? That if the board gets bigger, the housing gets bigger. The same is true of antennas. In fact, the way antennas work, it's the dimension. An antenna can see everything in the assembly. If it can see, for cellular as an example, if it sees a tower a mile away, it can see your finger on top of the antenna. It can see the other parts in the assembly. It can tell how long the board is. So the antenna is very iterative with the mechanics another maybe misconception when we moved to internal antennas for products quite some time ago now. From the outside, you don't see them, and sometimes there is a perception that they don't require volume. That well, I'll just leave it at that. Some people will perceive that there's no real volume under the plastics for it, but it is required. It's a real part. It requires XYZ dimension, just like every other part. So make sure that volume is in there for your antenna. Otherwise, you will have problems. So the other thing for the antenna, and this goes for a lot of parameters inside a device, is you want to measure the performance of this antenna as soon as you humanly possible. And you're going to continue to monitor it for performance, because as other parts come into play, it can degrade the antenna. The toughest one, I think, is for the antenna is for cellular application, because the carriers are deeply concerned with this, and they have tests that you have to pass. So I have seen people that will finish the development, run through it all, just throw something in there, and then measure it right before. It's right after they've tooled housings. It's after they've ramped factories. They throw it to AT&T, and then it will not pass. And those are hard, sad stories. So that's something you want to avoid. And it's easy to do once you think about it. Just plan for it. Prevent having to work or rework something. You know, in the worst case, in that scenario, you'd have to, in order to pass the test limits, you'd have to rework your board, your antenna, and your tooled housing. So you want to avoid that at all costs. Okay. So when you go through all of that, you do want to review. So, you know, you'll start with a first set of assumptions, and some of those things as you get into it will shift, right? You're picking parts, and they have so many options. They may be dead on the money for what you wanted, or you may have had to make a slight concession, but you need to go re-review and make sure that everything is correct and it works together. Again, measure twice, cut once, because we're getting ready to make further investment into the program at this point. Go through your current consumption. If you need to change something, this is the time to do it before we get going in. We bring more staff in to close this thing out. And again, common sense: measure twice, cut once. All right. So here's a double blue orange, right? So advance any effort possible. So if you've got a program and somebody is early, or they could start early, advance it. Just advance it. Don't wait. The only reason you really want to is if there's a dependency. They have to receive something from somebody else. The specific thing for an electrical development is vendors, and this is a slight overstatement, not every vendor, not every chip has one, but most of them do. Buy some dev kits. These things are mostly cheap. They should be cheap. Some people will charge a premium, but I'd still pay for it, because while the board is being designed, you can kick off your software development ASAP. If you remember in the beginning, we said, you know, long lead times, kick them off early. Software has that long green tail at the end, and you want to start early with software. So they can exercise that chip. It has, the dev kit has convenient hookups to measure things, talk to the device. You want to get going on this early. So advance it, advance it, advance it. The other thing that is a benefit, it's not as much of a benefit, but it is a benefit, is, you know, a hardware guy could go over and measure current consumption. So if there's a, the spec sheet's got a number, he wants to go measure it, confirm it, he can do that on the dev kit. All right. So roll through this, what actually happens in these efforts, and this is on our way to creating the PCBs. And I didn't mention at the beginning, but this is a hardware centric development discussion, but we'll continue with that. So the schematic, you know, you'll see a schematic entry on a workstation, and it looks a lot like just CAD work. You're hooking things up. There are these different symbols and things of that. The CAD work is it's the documentation of all the design work that goes into it. So if you take any part, they have a spec sheet, and in a typical design, you're going to go through hundreds of pages of data sheets, and then there are integrators manuals, and there is a boatload of information that's processed and gets documented in this schematic. It's like for an architect, you know, they've got a blueprint, but that blueprint, the work behind the document has load calculations and all sorts of things. So schematics similar in those regards. It's the design. It's the heart of the design. So you're going to put in a substantial effort into that. Again, it's this pyramid, right, where we put this in, and there's more work that will go on top of that. So we want to make sure that this work is correct. One thing that helps a lot with this, this was not the case in years back, but a lot of these symbols that go on the schematic, you can get them free and easy online. You should always check them, but they're there. It just saves time and effort. Next one is component placement. So it's not a jumble. You need to put these parts down in a good fashion. There are functional areas where parts will want to be condensed. There are smarter and less smart ways to array those on a board to work better with each other. And it will definitely optimize performance, and it can prevent a build to fix issues that you put in. So you want to get this part correct as well. This will generate a PCB outline, right? If you can imagine clusters of parts here, 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 and here, that turns into square inches, and that turns into exterior dimension for the housing. So, be prepared to iterate here. If you have a petite design, you know, you might get the final dimensions for the boards, and then everybody thinks that's too big. So you've got to either get real creative. It could lead to something more expensive. It could lead to a change of requirements, but this is where the rubber meets the road as far as that mechanical dimension. Again, there are footprints. Those are the PCB footprints for the part. Those are mostly online, or a lot are online. So try to take advantage of that as well. Layout. So now we've got all the parts on the board, and we're going to connect them. I've got a friend who calls these buildings and houses are the parts on the board, and there are roads that connect it. So now we're going to lay the roads. If you look at the detail of the roads, of the traces in the PCB, it can be extremely dense. You can have a simple board with 2 layers. You can have 4. 6, 12. I mean, it goes up and up depending on what you're trying to achieve in the product. And less is more for cost. But as you jam all of those traces together, you can have traces that disrupt other traces. So higher power type of lines can disrupt sensitive lines like a receive type path, things of that nature. They're picking up crosstalk or signal. So there's some art and some experience that goes into this. Now, probably a good question from the crowd would be, hey, what's the list of tips and tricks to make sure you do this in a good way? There are different things, but there's a golden rule for engineering, just like there's a golden rule in life. The one that I would say applies here is know thy design. So you know that product and those buildings and houses inside and out. And you think about, if I put this function next to this function, what's it going to do? Do I have, if I'm connecting the K to the N, I want to go this way. I don't want to have a connection that goes this way. And you really need an engineer to become immersed in this and think about this at a great level of detail, because if you do have a mistake, let's take an example. You've got a 4-layer board and you have a trace issue in the middle. When the boards come back, you can't redo those traces in the middle. So you're stuck with them. So again, measure twice, cut once. Just make sure you get this right before you proceed. And these are some of the things that you'll think about. You know, one line interferes with another. Here's another one: power handling, large current requires larger trace, etc. RF dimensions for impedance matching. So there are a number of things to think about there. Okay, mechanical iteration. So you guys are getting this. I can really just send you home with a couple of gifts and you're fine. But you know, you will crank the tools these days will crank out the layout tools will crank out step file, which is an interface to the mechanical team, and they will pull that in. You know, there are all sorts of things where the mechanical assembly and the PCB assembly interface, screw bosses, connectors, housings, things of this nature. So you need to be good friends with your mechanical engineer and talk with them frequently at this point, because now you're starting to affect yet something else, which would be the mechanics themselves. So we want to make sure everybody is happy at this point. And again, you know, some of these things I'm telling you guys, some things that are bad things that could happen to you, they're all preventable, right? Just the deal is you want to know about it, plan for it, and prevent it, because rework does cost time, money, and frustration. All right, this is $1 million question. So how many PCB spins? So the answer is 2. I have heard some thoughts, can you do the whole design in one PCB spin? Technically, anything is possible, right? You know, I don't know, pick a football analogy and how far you can kick a field goal. I've never seen it done. I almost saw it done one time, but I would say you're crazy if you're betting on this. Now I've seen some that go 18, 20, and they're not well controlled. So if it goes past 2, there's a real good chance that that one of the items we've talked about early in the program wasn't done as well as it could be. And again, that's system cost. And I see Gregory raised his hand. So let's see if we can answer Gregory's question.
Greg's question is, please define PCB spin. Does that mean design revisions?
It does. So that's a good question. That's just some lingo. So spin is a hardware revision that you send to the factory. So I call it spins. You could hear revisions or a hardware cycle, but how many times you build the board essentially. All right. So again, oh, go ahead.
I said we're good. Thank you.
Okay, just want to make sure. So think about that too from a system cost perspective, right? This is actually a very good example. So if you planned on 2 spins and, for whatever reason, things were not planned appropriately and you ended up at 6 spins, your system cost is ballooning, right? And we've seen that. It can be avoided. The other thing I would tell people in general is there are different things that require different levels of skill. So, if you need help with something that's at a higher skill level, or it's a technology that you just don't have familiarity with, just call somebody in. Could be us, it could be somebody else, but that will big time save you money. So you might, in that situation, pay a little bit of external cost to get some guidance, but it'll save you months of schedule. These can be tough when those happen. All right, so here's some closing generalities, and this, you should have heard this before, I hope so, but this is not mine for sure. But test early, test often. It doesn't really cost that much. It might be a hassle or feel like a hassle from time to time, but when things go sideways, and they really can with electronics, you can't see it, you can't feel it, you can't taste it, right? It's not like a mechanical thing. You have to get in there and measure it. So make sure it's working early. Continue to make sure something hasn't changed. We've seen things in production that change as parts may change or things of that nature. So you want to do that all the time. Another thing to think about is compliance is a real thing. The FCC can fine you. They can stop you from shipment. So if you think, and it is, compliance itself is kind of an expensive thing. It takes time and money to get through it. But try non-compliance. Try going through a 6-month schedule and not being able to ship the product because you haven't gone through the steps that are required. That's a very expensive thing. So that would be like I say the nonlinear risk. That's a bad one there. Speaking of the FCC, if you have anything electrical in your product that operates over 9 kilohertz, the FCC wants to know about it and test it. So if the only products I can really think of that fall into this are, toasters, things of that nature, light bulbs. If it has any processing capability, you've blown right past this. And it's not just radiated frequency. This is crystals, anything in the product. And again, non-compliance is very expensive. The other thing about certifications, I was thinking about how to tell you guys this, but certifications, kind of like the memory thing, you never see the memory requirement go down. I hazard to say you're never going to see a compliance schedule just get faster. They're slow, and you can put some cushion in for it, but that is a slow part of the project. You'll end up interfacing with some external labs, and be prepared. Do not be shocked if that's a slow thing. Your costs won't necessarily explode, but time can can drift in compliance. So that's something to be aware of. And again, you want to make sure it's going to pass before it goes to that lab. So you have to do the pre-test to know that. You lose a lot of time if you get into a formal lab and you fail. And all of this obviously depends on intricacy, right? So if you have 5 radios in the device, you're going to have 5 times the testing, and you need to plan for that accordingly. Okay, so that's it. This is, if later next week you have a question or anything, feel free to get a hold of me. And with that, we'll open it up to general questions.
Thank you so much. Folks, are there any questions for Will? If you have any, please feel free to put them in the chat. It's a really great presentation.
Well, there's got to be a couple questions out there.
Don't everyone come at once. Our first question is that you mentioned lower frequency for onboard non-cert modems. Can you elaborate on that, please?
Lower frequency, or here, say that again. Lower frequency for
onboard non-cert modems. Better propagation. And Joe, maybe let me unmute you, and it might be easier to verbalize that. If you give me a moment, please.
I think I know, but let's hear it first.
Okay. Joe, go ahead and you can unmute yourself.
All right, hey, Will. Yeah, sorry, hard to explain through the chat. I think one of the slides earlier on, you mentioned with if you have kind of like a module modem or something, you have better propagation through like a garage or something like that. But if you put it on the board, maybe it was a little bit different, or it could be the opposite, vice versa. If you were to put it on your board, it's better propagation in that setting. I was interested in that. Maybe I misheard it, or do you have any more details on that if you know what I'm talking about?
I'll try to flesh it out. There are 2 different things, and maybe they're overlapped in there. So the first thing is for a lower frequency for the radio, you will have better propagation. So I'll give you some specific examples here. So I'm going to take the first one is LoRa at 915 megahertz. The second one, we're going to go Bluetooth or Wi-Fi at 2.4 gigahertz. And the next one's going to be Wi-Fi at 5.8 gigahertz, right? And you guys may have seen this at home or neighbor's house or something. The 5.8 can get disrupted fairly easily. It can definitely go through walls, but it'll go through less walls. There's another thing that it propagates. It has less range. So it's almost like throwing a smaller pebble in a pond. It'll only ripple the waves so far, and the lower in frequency, the further that ripple goes. So if I was doing let's say it was a hospital, right? And I want to communicate on that floor all through a whole bunch of walls. I'm going to go with a 915 system. I either need to go with 915 and have less radios to cover that floor plan, or if I, for whatever reason, have to go with 5.8, I better count on putting a lot more in there because it'll cover less territory. So that's the propagation standpoint. For a module, maybe you tell me, I'll expand, and if you have more questions, just ask. But for module, let's go with I'll take BLE. You can do a BLE chips down design. Like you can get a Nordic chip and put it down. You can design a custom antenna, or you could do an off the shelf, or you could have it be part of the circuit board. That might be design A. Another design B, is you get a Bluetooth module with an integrated antenna, and you slap that down. You will get better performance because you can customize the antenna to your mechanics with method A than B, but they'll still be in the same ballpark. They'll still be in the same ballpark. For that one, the module or the chips down, the big deal breaker there, or thing to think about, is certification costs. So if you buy a module, it costs more money, dollars. The company is going to have a profit on that module, and they're also they did get the product certified, and they're going to amortize that certification and charge you for part of the certification. So your piece part is higher with the module. With the chip, if you have a larger volume, it's usually about 10K if you do the math. If your volume's above 10K, in the long term, you'll save money if you just buy the chips that go under the shield. You do it yourself, do the design yourself, and then you get certified yourself. So I don't know. Tell me if that covered the base.
Yeah, thanks. That was exactly it. So that was a good answer. Appreciate that.
Awesome. Thank you, Will. The next question that we have is, what types and scope of project assessments does Device Solutions offer?
So, I tell people we will help A to Z. So A is you've got a sheet of paper and an idea. Z is you've done all the work and you're stuck at certification. You got that unfortunate notification that your product won't pass. We'll help people in the middle. So we'll pick them up all along the way. We do, for projects, we do have a lot of wireless background experience. We came from, we're in North Carolina. There was a Sony Ericsson facility here. A lot of us worked there. Some of us worked at Motorola, places like that. So we do a lot of wireless, but we will also do non-wireless as well. So if you had a generic system, like we did one, it was really cool not long ago. It was a charging cart for classrooms where it's that was a 1500 watt system. You're charging 30 Chromebooks. You're using, instead of traces on boards, we had bus bars in the system that were about the diameter of your pinky. So we'll do things like that as well. So we've got a fairly good breadth. And like I said, we've been around about 20 years. We've done a lot of different stuff.
Wonderful, thank you. Well, we have about 10 minutes left and 3 questions that I have in the chat. So if anybody has any final questions to pop in the chat, please do so now as I read through the last 3 questions that are currently here. So the next question is, what kind of tests are suggested for RF susceptibility?
Susceptibility, you'd want to see 2 different things. If it's if the product itself is susceptible to an external field, so you'll take that into a lab and it will be, you'll hit it with a large signal field, right? So it can, if you do that, it can do, in the absolute worst case, it can cause damage to the device, but more frequently, it can reset the device. So, and these are, they're large signals, so they'll measure the volts per meter that you're hitting it with. And that is that takes experience too, because you don't really plan for that type of environment. You just really need to get in there and test it. The other one that you need to, which is more mundane and falls under susceptibility, is ESD stress. So that's, you know, the old thing, touching the doorknob in the winter and that spark jumps off your finger. You can take that to a lab and they will take basically a little gun that creates the little spark. And if that gets in, it can easily reset a device and things like that. It can, in worst case, cause damage as well. So those are general things. And you would test that. ESD, everything should get tested as long as there's a human touching it, which is everything. The higher power things, it just depends on the application.
Thank you. The next question is that I'm looking to build a high bandwidth radio modem using a unique patented waveform. Any particular issues to watch out for or suggestions for RF engineer groups to work with?
I'd give us a call for starters. We can talk to you about it. And it depends on, well, the other thing I'd tell you, for one, I'm somewhat biased. But the other thing I'd tell you too is we're fairly straight shooters. So if it was a 60 gigahertz design, that's above our typical, and we would try to steer you in the right direction. We do stuff, the bread and butter, I would say, is from 6 gigahertz and below. That's where you'll see a lot of activity. Our highest is 18 gig, but there are just less things being offered up there. So it depends on the generalities of that, but we could give them some good advice either way.
Greg says that he's looking at the 915 ISM band for object penetration.
Good choice, right? So the discussion about propagation, it's ISM, so it's cheap. I don't know if that's, Greg, if that's penetration through walls or if you're, you know, ground penetration or what types of objects those are, but I would definitely say lower is better.
And we can definitely make a connection, Greg. Says he'll call you this afternoon. But the next question
could be more. Oh, go ahead. I was going to say could be more iterative, and that's fine.
The next question that is in the chat, and this is the last one that I'm seeing, is: are there any vendors or companies who offer semi-customizable devices which fill the gap between an off-the-shelf device and a fully self-developed designed device?
There definitely are. It depends on what you're looking for. So, you know, we have one, we do design services. We do have a LoRa product that can help people. It's a little more, that particular one's a little more industrial. So if it's a box shaped thing. If you can live with something like that, there are definitely products out there. And again, just give us a call. I don't know what the details are, but we can usually say, yeah, here's a couple of vendors that have an offering.
Wonderful. Any final questions for Will? Well, seeing none, thank you so much again for a wonderful presentation, Will. I hope that everyone has a great rest of your day, and we will see you at the next Lunch and Learn.
Sounds good. Thank you to everybody.
Thank you. Bye.